Yeah, good morning to everyone. Let us begin the session. In earlier session, we already seen what is function, what are the types of function like one-to-one, into function, on-to function, bijection function. And after that, we straight away started with understanding of when we say the function is increasing, strictly increasing function, strictly decreasing function, something like that. So in today's session, we will quickly go ahead with respect to one more component. That is, we already seen what is composition of relation. So function is nothing but it's a relation. The same thing, composition of function. So let me just open that quickly. Ah, in the last session, we started with the inverse function. Okay, interesting property. So if the function is bijective function, then and then only inverse exists. Inverse of function exists. Otherwise, if it is not bijective function, inverse function do not exist. Okay, this is most important property. The inverse function of bijective function f from A to B is the function f inverse from, see, if the f is from domain to codomain, then the inverse of f will be from codomain to domain. Subjective, this function is bijective function. So whenever you are having f of A equal to B, now from this, if you want the pre-image, you need to apply the f inverse of B. You will get A. Yeah. The next thing is composition. The composition of two functions. Suppose you are having two functions. One is from A to B, that is G, and another is from B to C, that is H. So the composition of function, that is f of G, you can pronounce this as f of G, is defined by G. I will just first show you visually. If I will have no. Yeah. So let f be a bijective function from state A to state B. The inverse of f is f inverse from B to A. If the inverse function of f exists, f is called invertible. Means what? If the inverse of function f exists, means what? If we map one of the element from domain to codomain, we are able to again go back to its pre-image with the help of f inverse. If f is not bijective function, it is not possible to define the inverse function of f. Why? Because if f is not one-to-one, let us say this is a function. Why? Because every element of domain is mapped to unique one of the element in the codomain. So this is a function, but this is not one-to-one function because this element belonging to codomain is having two pre-images. So f of this is this, f of this is this. But if we want to know who is the pre-image, means we want to go back. It is just like assume you are having here 2 and here you are having 2 and the function is let us say square. That if you give the, you need to map this 2 to 4 minus 2 to 4. So you want to know f inverse of this, then there is no unique pre. That's why f inverse is not a function at all, because you know what is the function definition, that this element, if you want a function from B to A, element belonging to this domain should have exactly one image in codomain. If we are talking about F inverse, that is function from this to this. So you can see this element is mapped to more than one element. So therefore, inverse do not exist if the function is not. Now straight away going ahead, if F is not a bijective function, then it is not possible to define the inverse of F. We already seen this. Mm, hmm. What we are talking right now, the composition. Wait. So let F be a function from set A to set B. This is domain and this is codomain for this function F. And let G be a function from set B to set C. So this is domain and this is codomain for this function G. So the composition of the function G and F denoted by G composition F, G of F A, that is G of F of A, means what? You want to identify this element is mapped to, it is just like there is a transitivity. You can see there is a function from A to B, there is a function from B to C. So we just try to identify this element is mapped to which element in the codomain C with the help of composition operation. There is no direct function here. You are able to map element from A to B with the help of F. You are able to map element from set B to set C with the function G. And now with the help of F and G, you try to identify what is that element, means element from set A is mapped to which element in set C. So this operation is composition of function, and this is what we already discussed in the composition of relation also. I, I think I have not noted here, but we already discussed this composition of relation. So coming back, so what exactly we need to identify is how to get that element. So let's set A is 1, 2, 3. Set B is A, B, C, D. There is a function G from set A to set A. There is a function F from set A to set B. You can see 1 is mapped to 3, 2 is mapped to 1, 3 is mapped to 2. Okay, if you are not able to visualize, let me just show you here. Okay, all right. So let us assume we are having some elements here. This is set C, assume. And you do have function F2, which is mapping from B to C. Okay, so let us assume that F1 is one function that is, let us say, 1 comma a, just writing arbitrarily, 2 comma b, 3 comma e, 4 comma f, 5 comma c. One of the function. Fine. Let us take f2 function that is equal to a comma 10, a comma 13. Okay, there are multiple elements, so 23. Let us see. All right. A comma 2, b comma c comma this is one of the sample functions. Okay, assume these are the two functions given to you. So there is a function f1 which is mapping from set A to set B. There is a function f2 which is mapping from set B to set C. And now what exactly we need to find out? Basically, what exactly we are doing here? For example, f1 of A, if I want to know, that is equal to what? That is equal to f1 of, sorry, not A, f1 of 1. That is equal to f1. Okay. So what we want to know, what is that composition function, so that we are able to map elements from set A to set C directly. So to get that function, what exactly you are doing? You are doing the composition of G of f of A. Means what exactly you are trying to identify. I want to know what is this element. Sorry, this element is mapped to exactly which element. So to get the answer, you know very well this is the codomain and it is having a pre-image in this. So we need to identify this is mapped to whom here, so that we are able to answer this is mapped to whom here. So for that we need to know what is f1 of A. Once we get the pre-image for this, then we need to just apply f2 of f1 of A to get the answer. So what is this? f2 of, what is f1 of A? That is A. So what is f2 of A? That is 2. So basically f2 of f1 of what is the composition function. Now how you will denote this format? It is denoted formally like this. G of f of A means first which function you are applying, then which function you are applying, then which function you are applying. So you are just going right to left. So first this function is applied, then these, something like that. And how exactly we evaluate this? Going from right to left, whatever the function is there, we just supply this input parameter to that function, that is f1 of A. Whatever the result we will get, that we will supply to this function. Suppose you are having another k of g of f, whatever the result of this you will get, that you may supply some another function also, that is h also, something like that. Okay. So coming back here, how we write this? This is written as F2 of composition, F1 of, you need to supply the input parameter, that is A, that is equal to this. So this is called as composition of a function. Nothing different, it is same thing what we discussed in the relation. Same thing. Okay? Hmm. So the composition of two functions, G and F, denoted by f of G. So you need to identify G of A and then f of A. This means that first the function G is applied to the element A belongs to A, and then the function F. Here the ordering is different because we are talking about G and F. Don't get confused. So we already discussed this. One more point here of further discussion. The composition of a function and its inverse. If you apply f of x, and if there is an inverse of f exists, if f is bijective function, then if you do f inverse of f of x, you will get the same function, same element back. The composition of a function and its inverse is the identity function. This is what you already studied in your elementary school level algebra and geometry. What is the inverse function? So f is a, suppose this function f1 is a bijective function. So going from this set to this set, you are having a function. Okay, coming back here. Let me go back. Hmm. Yeah. So yeah, here this is not the inverse function. I require some example to illustrate here. Let us assume you are having one-to-one and onto function. Mm, Need to check here whether I have written. Okay. So let us assume 1 is mapped to B, 2 is mapped to C, 3 is mapped to D, 4 is mapped to E, 5 is mapped to F with the help of function F1. And if this is a one-to-one and onto function because every range is equal to codomain. And
Range
what is the
range
function?
got three.
Pardon?
Range
Pardon?
got three.
तो स्क्रीन
I'm not.
फ्रीज हो गया है.
Oh,
हाँ
okay.
सर,
Wait. Screen is what?
एक जगह अटक गया है जो आप बता रहे थे
Wait a
ना।
minute. Is it visible?
यस सर।
यस सर.
Okay. So I am opening now the Excel file. Is the Excel file is visible?
No sir, Google Meet चालू.
Oh, so I hope now the Excel file is visible.
Yes, sir.
Yes sir.
Okay. Okay. So what point I am highlighting here? Let us assume one is mapped to B, two is mapped to C, three is mapped to D, four is mapped to E. Hypothetically assume five is mapped to F. So this is function F1. And what is the inverse function? See, inverse function of F1 exists only where F1 is bijective function, that is one to one and onto function. So what is the inverse function F inverse of F1? That is what? B is mapped to 1, C is mapped to 2, D is mapped to 3, E is mapped to 4, F is mapped to 5. Okay, so this is inverse function F. So what is the point that I am highlighting right now? That let us say you are having function F and F inverse. So if you do F inverse composition F for element X, so what is that? F of X, this whatever you will get in that you will apply F inverse of F of X. So what is basically, let us say this is X, its image is X dash, let us assume. So what is F of X? F of X is nothing but what is the image of X in this under function F, that is X dash. So F inverse of X dash. So F inverse is a function which is mapping from codomain to domain, that is B to A. So F inverse of X dash is X. So what is the point that we are discussing at present is composition of function and its inverse. If you have a composition of function with its inverse, we will get the same element back. The composition of a function and its inverse means if you do the composition of function and its inverse, you whatever is the resultant G you have written here, sorry. F inverse OF, that is this composition. This composition, we call it as an identity function I. Why? Because whatever input argument you will supply to this composition function, you will get back the same element itself. Means X is mapped to itself. Because you are mapping from domain to codomain. Means X is mapped to in the codomain, and again from codomain to domain you are mapping. Since it is a one-to-one onto function, this is mapped to itself. This is what I am discussing right now. So is it clear or not? Let me know in the chat box what is identity inverse function and what is identity function. Please let me understand whether there is any difficulty for understanding so that I will repeat if it is required. Please respond in the chat box. Is it clear or not? Yes or no? Okay, Chetan is saying repeat once again. No issue. I will repeat once again. But Chetan, I need your feedback. Can you unmute yourself so that I can understand where you
Yes,
are
sir.
stuck?
Yes,
So
sir. So
Chetan,
this
can
identity function.
okay. First of all, composition is clear or not? Let me understand.
Yes, sir. Composition clear.
Clear. Okay. Going ahead, one-to-one onto is clear.
Yes,
Bijective
sir. One
functions.
to. Yes, sir.
Okay. Now, what is identity? Basically, identity function is not a separate function. What we are talking right now, if a function is a bijective function, that is one to one and onto. Let us say a function f is one to one and onto, that is bijective function. Then you are aware that every bijective function have inverse function also. So if we do composition of inverse function with that function itself, what does it mean? When we do this composition, what does it mean? How it will get evaluated? Going from right to left. So whatever the element that you have taken, you will first of all find out f of x means what? You will try to find out what is the image of x. X belongs to domain. There is a function, there is a function f from a to b. So element x belonging to set A under function f is mapped to whom? This is mapped to x dash somewhere here. Okay. Is it clear,
Yes, sir.
Chetan? Yeah. Now what we are talking right now, we are evaluating this composition. So f of x is x dash. Since we do have f is a bijective function, its inverse f inverse will be also bijective function. What is this f inverse? F inverse is from set B to set A. F inverse is from set B to set A. So you do have here x dash. It is mapped back to x with the help of F inverse. So x inverse, x dash is mapped to x with the help of function F inverse. So what exactly we have done? F of x we identified. Then we got F inverse of f of x. What is that element? We are having element x belonging to domain. So we started journey from domain, that is set A. F of x, we went to set B because f is a function from A to B. So f of x, we got something. Okay. Now there is a function f inverse which is from set B to set A. So f of x is element belonging to codomain. F of x is just something x dash. So f inverse of f of x, f inverse of f of x is again back to element belonging to domain, that is x. So whatever this composition we have done, we are talking about this part. F inverse composition f of this element x is always resulting into that same element x. So this f inverse composition with f, we may label it as some function I. Some label, nothing else. It's not some new different function. We are just labeling F inverse composition F as I. And we call this I is a identity function. Why? Because if you perform I of X, you will get X. This F inverse of is nothing but your I function. That's it. So is it clear
Yes,
or
sir.
not, Chetan?
Yes,
Okay.
sir. Yes, sir. Clear, sir.
So going ahead. Done. So okay. Mm, okay, there is some property of composition. Let me clear this. Let us assume if, if X is belonging to set A, and if there is a function f from set A to set B, X is mapped to f of x. F of x belongs to set B, and there is a function g which is mapping from set B to set C. So f of x is mapped to some g of f of x. Okay. So what is composition of g o f of x? That is equal to this. This is what we have just now discussed. So x is mapped to g of f of x. G of f of x means this is a composition function which is mapping from A to C. Okay. Please remember, if f is a bijective function, g is also a bijective function. Then and then only g o f, that is composition of g with f, is also a bijective function. Otherwise, no, it cannot be a bijective function. And if it is a bijective function, you can have a inverse also exist. Every bijective function is having an inverse. That's it. Now there is one important property that you should remember, that we need to understand whether composition is satisfying commutative law or not. That means what? What is commutative law? Let's say plus means addition operation is satisfying commutative property. What does it mean? If I have given two elements x1 and x2, so whether you are doing x1 plus x2 or whether you are doing x2 plus x1, result is same no matter what is your x1 and x2. So for all possible values of x, if this x1 plus x2 is equal to x2 plus x1 is true, then we say the operator is satisfying commutative property. So similarly, we need to check whether this composition is also satisfying commutative property or not. That means what we need to identify whether FOG is equal to GOF. This is we need to check. So, what is your opinion? Whether it is satisfying or not satisfying? What is your guess? FOG means what? Okay, first of all, G of F means what? It is mapping from set A to set C. So you will be having order pairs C. FOG means what? It is G of X that you are identifying. G of X from this set or something. To understand. Okay. So let us say the function f is defined from A to B, f1, whatever, f1 that is equal to, let us say, 1 comma 1 comma a, let us say 2 comma a, 3 comma b, and there is a function f2 from set b to set c. Let us say it is something like this: a comma s and b comma r. Okay. So now what we need to find out, what is f1 composition, f2, and element we are taking from set A, that is uh, we are talking about f2, no? Wait a minute, let us say f2 composition f1 and element is 1. So how we will get this? That is equal to f2 of f1 of 1, that is equal to f2 of f1 of 1 is a, so that is equal to f2 of a, that is equal to s. So what we have done, we have established a function from A to C that we call it as a F2 composition F. Fine. Now what we're talking, is it satisfying commutative properties? So we need to check what is one composition two. So if we need to uh, give the input argument, it should be given from which set for this composition function. This composition F1 composition F2 is basically from which set to which set? Can anybody tell me? As you have seen here, F2 composition F1. So first you are applying F1. So F1 is from A to B and F2 is from B to C. So we are getting F2 composition in F1 is nothing but A to C, because A to B we map and then B to C we are mapping, and basically we are trying to get A to C. So F2 composition F1 is A to C. So similar F1 composition F2 is from which set to which set? Can anybody Can anybody tell me? F1 composition F2 is from which set to which set? Yeah, Chetan, can you unmute?
Yes, sir.
Yeah,
It
tell
is
me.
C to
F1
A.
composition. Why? Because F2 is from which set to which set?
So
F2.
F2,
See how we are going from right to left, no? So F2 is on which set to which set?
F2 is
F2 function.
B to C.
Yeah. So B to C. We are going from B to C. So we need to give element from B as an input for this. We get its image in C, and then F1 of C. Are we able to find out? Is there any F1? F1 is from whom to whom?
A to B.
So it doesn't mean that it is satisfying the composition property. You can mute now. On the basis of this also you can see we do have a mapping function from A to B. We do have a mapping function B to C. Okay, but it doesn't mean that we f of sorry f2 composition f1 means first we are evaluating f1, then we are evaluating f2, means we are moving from A to B and B to C. F1 composition F2 means what? We need to evaluate first F2, that is B to C, and F1, then we need to apply. If this is same set like A, B, C, if the elements are same, then we may have commutative property satisfied. Otherwise, it is not possible to satisfy this commutative property. Because when you do A to C, when you will say it is satisfying commutative property when F2 composition F1 of X is equal to F1 composition F2 of X. Means if you are having here element X in general, that is equal to then and then only you say this is holding the means composition properties commutative, but it is not obviously true. Therefore, what is the learning lesson from this? That the composition operation of a function is not commutative. So now we will check whether it is satisfying the associative law or not. Now what is associative law? As everyone knows, associative law means what? You have been given three elements. So you need to add these three elements. So whether you are doing x1, x2 first, and then you are adding with x3, the result. Since you know addition is a binary operator, so it requires only two operands. Whatever is the result, that is one operand plus x2, or you may do first x2 plus x3, and then whatever is the result with x1 addition. So you can see it is always true. So addition operator satisfies associative law. So same thing we need to check whether the composition operation also satisfy this associative law or not. Now what is meaning of associative law in terms of this function f? Suppose this is some set A, B, C, D quickly. And let us say there is a function f, there is a function g. So there is one more set that is d, and there is one more function from C to D that is h. Because we need to check now whether composition property is associative or not for the function. That means what exactly we need to check? What exactly we need to check now is uh, H composition, whether we are doing G composition F first, this is equal to H composition G that we are doing first, and then composition with F. This is what we need to check, whether it is holding associativity law or not. How to interpret this H composition G composition F? So what is this basically here we are doing? First, we are trying to, this is X, X is mapped to F of X, this is F of X. Okay, then G of F of X is here. Okay, and this is basically what H of G of F of X. Now, how we will interpret this? So first we are identifying F of X, that is this, and then we need to identify H composition G. So you need to understand H composition G means what? You are trying to establish direct relation from B to D. That is your H composition G. So whatever is your F of X that you are landing in set B, and with the help of this H composition G, you are establishing B to D connection. So whether you are going from, whether you are performing G composition F. G composition F means what? F of X followed by G of X. That means G composition F is this. This is your G composition F. You are establishing relation from A to C, and then H composition with this. That means H of this. That is A to C and then C to D. Therefore A to D. And what exactly here you are doing? You are just trying to identify F of X, that is set B, and H composition G means what? You are having relation from B to D. So either you are A to C and then C to D, or you are moving from A to B and B to D. You are trying to figure out A to D only. That is what we are discussing here. And yes, it is holding true for all. If there are more than two functions, FGS, something like that, associative property is holding. We will discuss more in the next session. What I will do, on Saturday, I am scheduling one extra lecture from 8 to 9. So this Saturday, we are again meeting on at 8 a.m. in the morning. I will create a link, and you will come to know the link only on Saturday. So let us get back on Saturday. We'll stop here, post your attendance in chat box.
So can you send the PPT
Yeah.
you show?
Okay, I will share this in the I think I have created one Google Classroom also, and on Kaizala also I will share this. Don't worry, I will share.
सर गूगल क्लासरूम का लिंक भी भेज दीजिए
Yes,
प्लीज
yes, yes. I will share everything. Okay.